Welcome back. So now when we have learned to conduct descriptive analysis, and we have also learned to see if our data are normally distributed, let's now see how to conduct correlation analysis. Correlation is actually a measure of how closely two variables are related to each other, and correlations value varies between -1 to +1, where -1 denotes perfect negative correlation, +1 denotes perfect positive correlation, and 0 denotes no relation at all. The perfect positive and perfect negative correlations do not exist actually. So the value is always somewhere between 0 and +1 or 0 and -1. A value of say +0.30 would indicate that these two variables are related with each other. The relationship is positive, that is, if one variable increases, the value of other variable also increases. And a value of say -0.5 would tell us that the relationship between two variables we are looking at is negative. That is, if the value of one variable increases, the value of other decreases, and this is a sort of strong negative correlation in which, or moderate negative correlation, in which both variables are 50% correlated. Okay. So now let's see how to conduct correlation analysis. To conduct correlation analysis, we go to correlate, we choose bivariate, right? And then we choose the variables between or among which we need to check correlation. So let's, for example, select all these variables. Okay. When we select all these variables, now we have an option of calculating correlation coefficient using Pearson's method, Kendall's methods, or Spearman's method. So the Pearson method is the most commonly used method, but its assumption is that your data are normally distributed, which we just saw in the previous video, that at least one of our variable is not, which we checked, is not normally distributed. So we should not be using Pearson's, or we can uncheck that, and we should be looking at Spearman's rho or Kendall's tau b. And we can check test of significance two-tailed or one-tailed. We choose two-tailed, and then we select OK. Now look at this. What we have here is Kendall's tau, and this is Spearman's rho. Kendall's tau is the most robust test, so we should be actually looking at that. Okay, so if you see, acquisition is correlated with application. The value is 0.535 and the significance is 0.000, that is less than 0.05. So we say this correlation is quite significant, and highly significant correlations are denoted by these double stars. Okay, so if we see at sharing, or the correlation between sharing and knowledge management, that is also quite high. Sharing and firm performance, that is also there, and it is also significant. However, you can see that the correlation between sharing and job performance is not significant. That is, its value is significance value this is the significance value, or p value, it is the same thing. Okay, so this is more than 0.05, indicating that this relationship is not significant. As I said, Kendall's tau is very robust, and its values are usually lower than other measures. For example, if you have a look at Spearman's rho, its values are greater than Kendall's tau. Okay, so this is up to you. Which one do you want to use? It is always advisable to go for when your data is not normally distributed and there are outliers, you should be using Kendall's tau. But if there are not, if outliers are not present, you can also use Spearman's rho. However, if your data are not normally distributed, you should not be using Pearson's R. Okay. So if you look at Spearman's rho, these values are greater than Kendall's tau, indicating that these variables that we are looking at are highly correlated with one another. So that is how you conduct correlation analysis. If correlation is present, then we can go for some other type of analysis, for example, regression analysis.